All right, guys, I'm back here too. I'm kind of splitting up these videos, so if there's one you feel like you need to watch more than the other, and it kind of just splits them up. I know that makes it a long time if you look at all of them, but that way the next few days, if there's certain things. Again, as a reminder, if you want me to go through any of this particularly with you, just let me know and we can line up a time to video chat. Even if it has to be like afternoon, evening, I totally understand getting ready for a test, how you feel. So this video is about determinants and inverses. There was one of the worksheets where I gave it and I thought I had said it, but some people didn't pick up on it or remember that. Please remember that this video right now, today, this part of this video, this certain chunk, can only be squares. So if I were to ask of the determinant of something that's not a square, you say can't find determinant not square. It's kind of like that dimension thing. Remember, the dimension thing is very important with matrices. So if your matrix is not a square, you cannot find the determinant. If your matrix is not a square, you cannot find the inverse. Now, on one of the homeworks, I did have the worksheet give you the inverse for a 3 by 3, but I never had it show you how to figure that out. And so you're not going to have to find the inverse of a 3 by 3, You're not going to have to find the inverse. You do have to find the determinant. All right, so we're going to review all of those. Determinant of a 2 by 2 is really pretty easy. You cross down, you keep that sign the same. When you cross up, you got to switch your sign. So let's look right here. We cross down, we get 3 times 6, which is 18. The 3 is negative on my problem, so we would get negative 18. When I cross up, I get 8, but remember that cross up was supposed to be the opposite of what I get. So I'm going to get negative 18 minus 8. Let's see, that gives me negative 26. So you would say like determinant, sometimes we say DET on this problem because it's right here. If it said find the determinant and you just wrote equals negative 26, not too opposed to that. Let's look at this one. Cross down, 8 times 4 gives me negative 32. 5 times 6 gives me negative 30. But remember, since that one is going up, I'm going to switch it. So negative 32 plus 30, my determinant here would be negative 2. Okay, determinant of a 2 by 2 hopefully is pretty easy. Determinant of a 3 by 3, we have not done that for a while because we've been doing determinants so much with inverse. Determinant of a 3 by 3. The first thing you have to do is copy down your first 2 columns. So please look down right here. You have 8, 4, 9. So right out here, we're going to write 8, 4, 9. You copy down your second one. I see negative 2, 1, 0. So I'm going to write negative 2, 1, 0. So this one, we're going to get a much longer list of numbers. I am going to use my colors. Hopefully they look different enough and hopefully they show up dark enough. So if you need to use a calculator for this, obviously you're going to have a calculator during your test and everything else as well. 8 times 1 times 5 is 40. That was a diagonal. I started from the top and went down, so I'm going to write down 40 and I'm going to leave it as 40. Negative 2 times 2 is negative 4. Negative 4 times 9 is negative 36. Since again that is a down diagonal, I would leave that as negative 36. 3 times 4 is 12, but 12 times 0 is 0. I'm going to write it there just so we remember we should have 3 down diagonals and all 3 should switch signs, but again 0 is not a big deal. All right, on our up. 9 times 1 is 9, times 3 is negative 27. Excuse me, I already switched it. On the way up, we got 27, but since that's an up diagonal, I have to write the opposite of what I get, which is 27 negative. 0 times anything else, I'm just going to swoop through there so I know. And over here, I am going to write plus 0. It is pretty nice if we get a 0 in the middle of a matrix. 5 times 4 is 20. 20 times 2 is 40. That 2 was negative, so when I multiplied up, I got negative 40, which means over here I'm going to have to write plus 40. Now, just to make sure we're getting that right, once again, I'm going to pick up this calculator here, and we're going to do 40 minus 36. I don't need to type in plus 0, minus 27 plus 40, and it looks like our answer is 17. Please remember when we're doing determinants, those, especially with the 3 by 3s, like if these wouldn't have been zeros, I could have a number that's way bigger or way smaller than 17. That could be almost anything. And I mean, we got a 26 with a 2 by 2. It really doesn't matter what's going on when we do this. It just tells us other information. Now, this was also a mistake by me. If your determinant is 0, that means there is no inverse, okay? If your determinant is 0, that means there is no inverse on that inverse homework paper. I did not. I thought I had looked through and had the computer not give you any, and there was one that was that way. So I do apologize for that, but I will make sure that does not happen when we're working the next few days. And so a couple other things. Number one, we are only finding the inverse of a 2 by 2. You do not have to find the inverse of a 3 by 3. I mean, if we were going to spend years and years and years in matrix math, I would make you know how to do it, but we're spending one chapter and we're going to be done in a few days. So after our determinant, the next thing we did was find the inverse. So as we look at finding the inverse here, a couple things to tell some of you. A lot of you need to listen right now. You don't just take the determinant and write it in front of your in front of your matrix. You got to flip a few things around. So if your original matrix started out with what I have written in black right here, an A, whatever number A is, B, C, D. And I don't know the signs of any of them. I don't know if they're positive or negative because they could represent anything. A and B, as you see with my red arrow there, I actually physically switched them around. You will pick them up and move them. But B and C, you keep them where they are. It might be kind of hard to read, and it's in purple. This is a plus minus symbol. So if B was originally positive, you're going to make it negative. If B was originally negative, you're going to make it positive. That's what I call the flip-flop. So if you're doing something, and like on test day, if you're doing something and I say check your flip-flop, flip means take these two and flip the spots. Flop, OP, stands for opposite, sort of. So sometimes I even spell it flop, F-L-O-P-P, with 2 P's to remember that those are supposed to be opposite. So I am going to, because we already did the determinant here, I'm going to say, hey, let's work on that, and then I'm going to give one more where we just have to find the inverse. You know, the first determinant we found was a pretty ugly negative 26. Negative 26, even if I distributed it, the 2 and the 6 and the 4 might reduce, but they're not going to reduce very nicely. So for the first one, we write our determinant out in front, please remember, but our determinant should be in a fraction. It is okay for you to leave the negative on the 26. Sometimes with fractions like that, we write the negative in front of the fraction. Please think about what I have written right here to remind a lot of you of. I have got to switch my A and my D, which means I've got to switch my 6 and my negative 3. But I am going to keep the sign. So the 3 stays negative, the 6 stays positive. I physically pick them up and switch the spots of them. Then for my other diagonal on this one, my B and my C, I keep where they are. So I'm going to keep this as a 2, but what type of 2 do you see right here? Thank you, it is positive. That means on this side for my inverse, I'm going to write negative. What type of 4 do you see? Yep, thank you. Again, it's positive. That means when I write my inverse over here, I'm going to write negative. Now, I've already mentioned this, but 1/26 is not going to distribute very nice into those values. So for this problem, I actually would not be opposed if you would say, hey, that is my answer right there. Let's work on the next one, please. We're still going to do this one, and then there's one more I'm going to do all the way through so you can see the work kind of all the way through. Negative 2 is my determinant, so I'm going to write 1/2, and I'm going to write my negative out in front. I got to take that 8 and the negative 4, pick them up, and flip them. So the negative 4 goes first, the 8 goes last. Next, I see a negative 6. That negative 6 has to become a positive 6. I see a positive 5. That positive 5 becomes a negative 5. Now, look up here. I said this was your answer. So if you really wanted to, you could put a box around this and that would be okay. However, I would like to say that if you have a half of 4, that's a nice easy answer. Half of 6, half of 8, half of 5, I hope in this level of math you don't actually hate that much. And so be careful because it is negative 1/2. Half of negative 4 and the half is negative. They're both negative, so I would get 2. Half of 6 is 3. There is only one negative, so it's going to be negative 3. This is the tricky one, maybe. Leave it as a fraction. What's half of 5? 5 halves. They were both negative, so it becomes positive. What's half of 8? 4, but only one of them was negative, so it's going to be negative. This right here says the word or. You don't have to write both. Quite honestly, on this one, I would probably expect this answer just because I hope you agree with me, distributing a half is sort of nice. So that would be my answer. This could be my answer, but it gets simplified a little bit, especially if we have to go one more step. Not to have that fraction out front is kind of nice. So let's do one all the way through where we just have to find the inverse. So let me think here real quick. Let's just think of some random numbers. 7, 3, 8, we'll do 4. And this time I think I do want to leave them as all positives right now. Sometimes they might not be. All right, let's do the work to the bottom. 4 times 7 is 28. 28. 8 times 3 is 24, but since I'm multiplying up, I'm going to have to switch it. 28 minus 24, I believe, gives you positive 4. All right, so we have 28 minus 24. Our determinant was 4. So out in front, we're going to write 1/4. Let's flip things around. The 4 comes up top. The 7 goes to the back, bottom end. The 3 is positive, so my new 3 is negative. The 8 is positive, my new 8 is negative. You know, that right there would not be the worst answer, but some of you are saying, hey, Miss Jabs, 4 and 8 would reduce pretty nicely with a 4th. I agree, so a 4th of 4 is 1. A 4th of negative 3 is a little bit ugly, but not, again, anything we should be too afraid of. A 4th of 8 is 2. Be careful, that 8 was negative, so the 2 should be negative. And a 4th of 7 is negative, 7/4. There was no negative on that one. That should just be 7/4. We could write the word or in between. And on this one, I said most of you guys, I would expect this answer. Honestly, for this one, it could possibly be either one. It might depend on which one you think looks nicer. Some people don't like this because they are not too excited about 4ths, so they would leave it this way. Some of you are like, hey, these two reduce nicely, and to have a fraction, 3/4 is not that bad of a number. I agree. So again, guys, I know that means all these videos, that's a lot to watch. But hopefully that means if you're like stuck on determinants, you can watch this one. If you're stuck on something else, you can watch the other one. I'm hoping tomorrow to do another review and do a few other problems with augmented and inverse for sure. But hopefully between all of these, you're doing okay and able to watch what you think you need. Let me know if you have any questions. Okay, thanks. Bye.